thank you for joining, and happy to have you here. This is a webinar about OPC UA FX. This is the third in our series of webinars that we work on to help everyone understand OPC UA FX. So we produce these webinars in collaboration with companies like Schneider Electric. I'm from B&R, Uthunga, and B Services. So we work together on producing these materials, and we welcome any other companies, individuals to present in these webinars. So today we will focus on OPC UA FX and simplifying secure industrial connectivity. And I'm taking a little bit maybe different approach with this. So I have a IT and telecom background prior to joining B&R. So I have added to this presentation some insights which I feel would have been helpful when I joined the automation industry to kind of make the correlation between the IT and the automation. Okay. Okay, so my name is Veli-Pekka Ketonen. I'm initiative owner and product manager at B&R. My focus is on OPC UA FX and industrial networks overall. I have added there my LinkedIn profile. I'm open to connect if you like. Just hit me with the connect button. My background, I joined B&R last December, and prior to that I worked at Ubiquity with a unified product line, which is targeted from small businesses all the way to the enterprises, IT, network devices, all kinds of things. I worked in the product development and technical product marketing, leading some of the teams there. Prior to that, I had a startup called 7Signal, which I started in Finland, and then we took the company to the US. And currently, 7Signal is about 50 people and 10 million business. And prior to that, I worked at Nokia with telecom networks. So that's my background, and I'm looking into things from networking perspective. So that's why as well I want to use this opportunity to maybe share some insights that might be helpful for those who come outside the automation industry or have not been able to correlate kind of the IT and OT things prior to this. So that leads us to the first concepts, IT and OT. And if you are not from automation industry, you may have seen OT, but you don't know what that's about. IT, I think we all know about IT. So basically you could say that OT is the IT for automation industry, or OT is the IT for machines, while IT serves the users, usually the humans mostly. So these have special differences, different focus areas. OT is really focused on keeping the machines running, always producing. IT is keeping the people connected. So different perspectives, usually different teams as well, and different skill sets. So recently these have been converging quite a bit because the machines become more connected, and it is a requirement to connect the machines as well. So it's not anymore usually acceptable to have a machine which is not connected at all to the other world. No air gaps anymore. So in IT world, there are these standards, connectivity standards like Ethernet standard, Ethernet. backwards compatible. You plug it in, it works. There is USB and most recently USB-C, very well known standard. There's Bluetooth, there is Wi-Fi, and usually these are backwards compatible. They all work together. So you can take a device from one manufacturer, plug it into the device from another manufacturer, and it just works. Well, in the operational technology area and in the industrial connectivity area, it is a bit more complicated. And I will cover this a bit here so that you will get a kind of understanding where everyone is coming from and where we are currently, and hopefully we can work towards the benefits that the OPC UA FX technology will provide here. So I'll use a little bit of time on this automation pyramid. So this is the kind of the concept for all the automation networks and plant floors and everything in automation industry. So field level is the lowest level where you have the sensors connected to a network. They might be measuring temperature or pressure or something like that. You have actuators there, which might be opening valves or moving objects or things like that. You have then all kinds of other devices. You could have there many kind of devices which are then connected to the automation network through a kind of a bus controller device, which is an interface to the network and provides access for the specific device to the network. And then, of course, you have there the robots, electric motors, drives which control the electric motors. So those are networked all together. And then to tell these devices what to do or collect this information, there is the control level. So there are the PLCs, programmable logic controllers, which control these devices. So they move the robots, they collect the information from sensors, and basically run everything in an automated manner. So going up from there, there is the supervisory level. So SCADA, it's like the operation NOC in IT maybe, where everything is monitored and there is visibility to all alerts, all KPIs, statistics, how is the manufacturing going. And so it goes further on there. But our focus is here in the field level and control level here. So I'll focus more on that. So on the right side, you can see typical network architecture for enterprises. So you can see router, you can see switches here, and they are layered like that. There's core switching, distribution switching, access switching, and then you see a ton of Ethernet ports there, which are then cabled to all the locations, one per location, one per user, maybe one per machine or something like that in the enterprise architecture. But in automation industry, this is slightly different. So the machines, they use a lot of kind of a line topologies. There could be tens of devices connected to each other. So for example, in this here, you can see a chain of devices. This could be 10, 20, 30, 40 long. And these are basically 3-port switches, each of these. So there is incoming port, outgoing port, and then there is the third port, which is showing is it for example a sensor, or is it something that needs to be controlled. So this is the way the networks are built. So they are built in line topologies often, and often as well there is a ring topology to improve reliability. So that's not so typical in IT world. So that's quite different. And then there is a mix of these topologies. Usually it would be star and ring and line and things like that. But most importantly, they are usually long chains of devices. And this is, of course, in a way challenging because you want to have exact time control, but that's where these new technologies come in. So these automation devices run in a control loop. Basically, it's a very fast loop. It could be 1 millisecond, or it could be sub-millisecond loops which control these devices. It could be as well much slower, depending on the need. But below 1 milliseconds are possible, clearly. So that's the difference here in the architecture and the automation. Okay. So then, what are the requirements for industrial connectivity? I mean, they are somewhat different than in the IT. So high reliability, of course, it's important in IT, and there are a number of nines and so on. But in manufacturing and in operational technologies areas, this is taken maybe even a bit further. So there are these ring topologies and various TSN technologies and features used to improve the reliability. So complex network topologies, we kind of covered that. So it's not a straightforward 3 down, certainly not. Deterministic communication, I think this is a key. So there are these 2 concepts in the kind of in time criticality aspect. There's a determinism, and then there is a isochronous communication. And in deterministic traffic, basically the arrival time to certain device is guaranteed. It's not when the information is sent, but when it's arrived. So that's deterministic. So full synchronization, messages get in at the exact time when they need to be there. So very important for synchronized communication. Interoperability, very important, and this is kind of lacking currently. We'll get to that in a moment. Cybersecurity, another challenge, and very important. And overall, environmental robustness and long product life cycles are important in the automation networks and automation machines and industry. Okay, so here is the challenge. So I'm not going to go through these all technologies, but these are the different standards, specifications used for machine communication. So there are several specifications, and they have been there for a good amount of time, and they are backed by different companies. They are usually all of them are neutral in that sense today, that there is a governing body and everyone is welcome to give feedback. But the challenge is that there are so many, and they are not interoperable usually. You cannot connect from the device with one technology to another device with another technology. So this is a challenge. So this is one of the biggest challenges, this interoperability in the automation industry. From my point of view, coming from IT, you can plug in Ethernet and it works no matter who's the manufacturer, basically. Not with the automation machines. Okay, so that's where the OPC UA and OPC UA FX can help. So OPC Foundation is an organization that develops specifications, open specifications for defining how the communication and networking happens. And they have been existing for a while, and there are extensive specifications available. They are as well IEC standard, and they are developing these specifications. And it's not really them; it's the group of companies that work together in working groups and initiatives to develop these new specifications. And OPC Foundation has, I think, about 1,000 members, and many active initiatives and groups developing the new specifications together with all the companies. So OPC Foundation is behind the OPC UA and OPC UA FX. And OPC UA and OPC UA is basically a collection of specifications for communications. So the challenge, like I mentioned, it's that there are so many of these industrial Ethernets or field buses. Both names are being used. So no single standard really. So that's the challenge. And this leads to kind of a lacking interoperability. You cannot plug in the devices together. Complex machines, sometimes you need to use multiple different technologies, and it makes developing machines really challenge. If you need to master different technologies and then you need to interconnect those, then it gets difficult. So you are kind of locked into a certain domain or certain technology, and that's where you are. And it is not a great position really to be in. So then thinking about the security, when you need to develop new security facilities to the machines, for example. So if you have multiple technologies included, then you need to handle not only those technologies that you have there, that they are secure, but you need to make sure that they connect to each other in a secure manner. So it becomes a challenge. So overall, many product variants, logistics challenges there. So overall, it's not a great position in the overall industry. And that's really where OPC Foundation started an initiative called Field Level Communications. And this was 2018. And the objective of this is to create specifications for field level devices, those sensors and actuators and robots and all those devices, how to connect them together and how to make them talk to each other so that it is interoperable and you can mix devices from different vendors. So a great initiative. So FLC started in 2018, and then the first specification, well, it took a little bit later than expected. 22, there was the first specification for controller to controllers available. So a great achievement there overall, and supported by all major manufacturers. So certainly a big challenge, certainly a big achievement to get there. But of course, it has been challenging, and it took some time to get there. So overall, that's the C2C controller specification in 22. So OPC UA FX comes in different flavors. So there is the kind of the base standard, core standard, OPC UA. We call it here client server. OPC UA, it's for non-real-time use cases. It provides interoperability and data modeling, which make it, compatible with devices from different manufacturers. It provides advanced security capabilities and connectivity from a sensor to cloud. So great benefits there. And it has been available, this specification has been available since 2008. Now we get to the FX, OPC UA FX, control to control specification, which was finished in 22. It adds this time critical communication for example, motion applications and things like that. So time critical communications added to the OPC specification comes through OPC UA FX control to controller. So this is between the controllers, which control certain sections of the machine or certain machines. Now the next step is to finish the specification for the control to device, which then covers the connectivity from each controller to each of those devices. Like they could be drives for motors. They could be those sensors which need exact time stamping and deterministic communication. So for field level devices, this is the next phase of the specification. And it will, of course, as well scale up the networks, because there will be so many more devices than there are controllers. So those are the three different, let's say, specification categories or buckets. which form the OPC UA FX. So the vision of OPC UA FX and OPC UA overall is to cover all communications needs in the industrial settings. So from sensor to cloud, and this OPC UA FX and this field level communication initiative covers these use cases, which are between the machines and then inside the machines, and this is what this OPC UA FX focuses on. So then I want to share some insights on the core technologies. Okay, which technologies make up this OPC UA FX? So there are a couple of key ones here listed. So time-sensitive networking, or TSN, is one of the key ones there. So TSN is as well used in other applications, but there is a specific application for industrial automation. I'll get into that in a moment. Security framework. So it is inherited from OPC UA and applied to the field level communication. So very important capability and feature. And then there is a PubSub, publisher subscriber principle, which is a multicast technique to improve scalability and speed. So we'll share a bit more in a moment. Time synchronization. So all devices have to be perfectly synchronized to kind of a sub-microsecond level so that everything works smoothly. And then final, but certainly not the least, semantic data modeling. And it is the kind of the specification and a part of the standard which makes devices interoperable, so that the machines have similar kind of interfaces. You would call maybe APIs those, but it's not really an API as such, but it is conformance to those specifications which make the devices compatible. Okay, let's look at the TSN. So TSN itself is a kind of a very broad topic. It is extremely thorough technology and standard, and comes in multiple smaller pieces. And one key one for industrial automation is the IEC 6802, which is a TSN profile for industrial automation. So that is made of number of IEEE specifications, individual ones, and they kind of add different functionalities to the specification. TSN itself is originated from this audio video broadcasting specification, which is an older one, and then kind of these more detailed specifications took over the AWB spec itself and then expanded further. So there are very important ones like time synchronization. So there is a precision time protocol to exactly make sure all devices have accurate timing. Virtual LANs are being used extensively. There is redundancy, kind of many different redundancy techniques, but one of them, for example, is duplicating the critical data, so sending it multiple times, which is one of the techniques. Then scheduled traffic, shaping the traffic, very specific means for doing that. So frame preemption and elimination. So let's say if a packet is being transmitted and it's being processed in a switch, and then another higher priority packet comes in. Basically, this lower priority packet may be just dropped out and to let the higher priority traffic pass the switch immediately. So this kind of feature. So stream reservation, path control, kind of ingress policing capabilities. So all of them add to this exact control of how the prioritization and the bandwidth is shared and used between the devices. So there is one more feature which is not a part of really TSN, but it's called cut-through switching. And it's a technique which is used, I think, relatively commonly in real-time traffic. So basically, after the switch receives the address, it basically starts forwarding it. It doesn't wait to receive the whole packet and then start forwarding them, but it just starts forwarding already during the receiving. So it's just moving the packet through the switch in a fluent manner. So many different techniques here being used for TSN, and these are all applied to the OPC UA FX technology. So okay, then at the higher level, what does this mean? Okay, what's the, in practice the meaning? So one way to look at it is here. So let's say that we have connected here in a line topology different devices. These could be switches, they could be integrated switches in the devices, and they are just put in a line topology. And now if there are TSN capable devices like these ones, then the traffic performance is guaranteed between these devices. So there will be no drops, there is a guaranteed latency. And then there are these different let's say, bridge capabilities or categories like full advanced base type of profiles, which can be applied to devices. The more advanced the profile, the more it has capabilities, and the better are the guarantees that the traffic will pass always. So interesting thing is here that you can see that these are all interconnected. So the traffic between these devices is guaranteed, while there may be traffic coming from left and passing to the right. So simultaneously, you can connect any device here, any Ethernet device, non-TSN device. It will enter traffic to this section. It will pass through. It doesn't have traffic, quality of service guarantees, but it will connect and go through while and during the time critical traffic is present. So very important there. And if there is a device in between these TSN category devices, then you don't have the guarantee between these two devices because there is a non-TSN device in between. So that's a kind of how the network is segmented, that you have these TSN capable segments in the network, and the performance is guaranteed while interconnecting everything else. Okay, then security framework, very extensive in OPC UA. There is so much, I'm not going to go in very much there, but with OPC UA, OPC UA FX, there is no need for air gapping anymore the machines because the security capabilities are all there. And there is a new regulation coming into force called Cyber Resilience Act, and I guess you may have heard about that in Europe. Very important driver for improved security in communications. And OPC UA FX has the capabilities to meet these requirements. Very important driver there. So then the PubSub is the next technology. So basically, traditional connectivity is a kind of a client-server connectivity. As well in IT networks, mostly use this client-server, is that you have a client requesting something and then server responding. And this goes on to one client talking to different servers and waiting for the response. And so it's one-to-one connectivity. And if you have a lot of servers and if you have a lot of clients, then this one-to-one communication becomes a little bit of a challenge. So high bandwidth, and you are not able to get the maximum performance anymore. So there may be delays, collisions, things like that. So PubSub solves this so that it's using multicast, and it's the publisher and subscriber topology here. So any device can be a publisher and a subscriber, and this can happen as well simultaneously. So a subscriber may basically subscribe to information like a temperature reading or any information from another device, and then this publisher will publish this information basically for everyone else as well. So it is an aggregated. So it's a multicast. It's being sent once, and all devices who are keen on receiving this information that can subscribe to this information. So it's one-to-many connectivity, and it may be a broker, there may be a device, specific device for that, or it may be a broker-less connectivity. So this gives the scalability and speed to the networks. So then semantic data modeling and information models overall. I think this is probably the most kind of in-depth area as well when creating the specifications for OPC UA FX. Is defining how the information is structured. So there are extensive facilities in the standard to define the information model. So the parameters, the attributes, the kind of the overall address space, everything. So there are methods which you can call to create transactions, and you can receive information both. So it's a kind of a bidirectional capability there. So this all is basically leading to a node set, which is an XML file with all this information in a certain tree or structure. And this structure is the information model. And you could see that, this is one way to represent the information model. So it's a tree of various nodes, and it's not only devices, but it's as well parameters and actions and things like that. So this is the information model, and this information model is basically the fingerprint for the device. And if the information model used in a machine follows the specification, it means that another device can directly access and use this information and communicate with this machine. So this information model is critical there, and it is the node set file really that defines it. So kind of going to the higher level then. Okay, what good does it do then? So it basically elevates the abstraction level to speed up the machine development. So if you have no standards, nothing agreed in common, you need to specify most machines agree how do we connect these two things. So it's going to be extremely time-consuming, difficult. And OPC UA specifications define the structure so that there are agreed rules what information to present, how and where. So you get great benefits for integration and development speed and security as well. So this is the OPC UA core, including then the OPC UA FX and field level communication additions. Now it goes even further. OPC UA standard supports companion specifications, which mean that there can be a specification, for example, for certain industry or certain type of machine, for example, a bottling machine or some machine. The manufacturers in this industry agree that, hey, this is a bottling machine information model. This is how we represent this. These are the parameters we provide. And if you follow these, you can interconnect these devices from different manufacturers, and it becomes really like a plug and play. You just put them together and everything works. So this increases the abstraction level and speeds up the development, hides the complexity of the information modeling, and overall hides this problem there is if there is no interoperable specification. Okay. So then when do we get what's going on with this, and how do we get to the adoption and get this to the market? So let's take a look at the benefits first. So first is the neutral, no lock-in interoperability. So there will be a broader selection of devices from multiple manufacturers, which can be interconnected. You are not locked into any specific field bus or standard. If you follow this commonly agreed standard, then you can connect these devices together from multiple vendors. So extremely important benefit there. Then the security, already mentioned the Cyber Resilience Act, very important there. So you can interconnect the devices as well between the IT and OT networks, because OPC UA security specifications are very much compatible with IT principles. So you can integrate these networks if you want to do so, and it makes it much easier to get the information from sensor to the cloud in a secure manner. So reduce development costs. So it is the agreed architecture. It is the kind of the elevated abstraction level to create machines. So basically, you have the fingerprint. You can connect the devices, and it will work like that. So then new data services, since there is the security and connectivity from sensor to cloud simultaneously, you can transfer the data all the way to the cloud, and machine builders can build new services on top of that. And I have the performance then there. So TSN is really the leading technology for high performance networking, and it is very important here as a part of the OPC UA FX standard. So great benefits there. So then if we, how do we apply this technology then? So here's a mapping between the core feature and then the core benefit. And this can be helpful when trying to decide that how do I transition to this technology. I'm currently using technology X, but I want to get to these, get these benefits, and I want to start my transition now. And I'm looking for certain benefits to kind of migrate in a gradual manner. So which technologies are the most important ones for each benefit? So if you look at this, these are the benefits: performance, security, interoperability, simplicity, reduced cost, and new data services. So all of them pretty much start with the OPC UA client server implementation, the current OPC UA specification. So you need to have that. So that's always a good starting point if you want to start building towards OPC UA FX capabilities, because it has the majority of the security facilities already there, and OPC UA FX is then applying those to the field level devices. So performance, basically you need to have the OPC UA specification, PubSub, TSN, and time synchronization technologies. Then for the security, you need again the OPC UA core, and then the security framework there. So to get the security benefits, if you want to have the neutral, the kind of interoperability aspect, then we are getting into this data modeling, same as for reduced development cost and simplifying machines, and those things. So they require this semantic data modeling capability, which then makes the devices connect to each other without too much pain. So if you want to start transition, of course, you can pick different kind of steps. But one way is to always start with the OPC UA client server or the current OPC UA specification. Start implementing that and capabilities there. Then you can either start more focusing on the security aspects or performance. So if you want to go for performance, you can start implementing TSN switching to the machines and to the network, so that you are then ready when you want to go further. You have TSN switching in place, performance capabilities there. So you can do the TSN and PubSub technologies, and then security, and then the semantic data modeling then comes in this list last, but it could be as well as elsewhere, of course. So depending on what are your priorities. So, but this is kind of one view to, okay, how do I implement OPC UA FX? One view to that. So then, where are we currently with the technology adoption then overall? OPC UA started with OPC Classic, and it's kind of a technology which is nowadays outdated, not supported anymore. So if there are any systems, just a reminder that life cycles are long in this industry, but if there are any systems using OPC Classic, I think it is important to transition to OPC UA immediately, and that would be the first step really. And so OPC UA specifications, I could say here client server, I've used the client server elsewhere, are available already, and there are devices, many devices, and many capabilities. Now, OPC UA FX then, it builds the real-time capabilities to the OPC UA specification. And it starts with this control-to-controller communication and use cases. So that specification is available already, and since 2022. And before the end of this year, I believe OPC Foundation will start providing certification capability or conformance testing capability for devices, so that you can make sure that they conform to the specification, and then they will be interoperable. So next year, 25. It is expected that there will be products launched to the market for control-to-controller use cases, probably quite many, we'll see. So it starts from here, control-to-controller. Control-to-device specifications started in 23, so it is using all the kind of the common parts from the C2C specification, and it is still in the development. And then that will be completed hopefully relatively soon. I don't have an exact timeline, but it is a high priority to complete those specifications. But it is really not necessary to wait for the final specifications, because you can start gradually moving into the OPC UA FX technology with TSN and PubSub and security and all these different capabilities, and then update the device to be compliant with the specification with software updates, and then you are compatible with all the devices and all the other manufacturers. So that's a strategy, at least what we are considering at B&R, or what we will be using at B&R. So of course there are field bus technologies still, and then they have the challenge of interoperability between them. You usually don't have it. Complexity, productivity in developing things, especially given the new security requirements. Security evolution, if we look at the new requirements for security, I think it may lead to some hardware requirements, like if you need to encrypt the data. Like it's not so common to encrypt the data currently in the machines. If you need to encrypt the data, that may mean that the existing hardware just doesn't support it. So there will be need to renew the whole hardware base. So when looking into renewing the hardware base, does it still make sense to maybe stick to the existing platform, or would it make sense to start using the common platform of OPC UA FX going forward? So that's the question. Of course, everyone needs to think about. Okay. All right. So our perspective is that we have been active in this domain already from the beginning of the FLC initiative. And we are committed to a full portfolio of OPC UA FX products. We already have some OPC UA FX C2C products. We call them OPC UA FX ready, because the conformance testing program is not yet available. But we have products to start with the C2C. And next year we expect to have the conformance testing for these products. And then the C2D, the devices, the motion devices, the robots, the real-time thing there. We have already a bus controller for connecting I/O devices like sensors and things like that to OPC UA FX standard communication protocol. So we have a device available there. Again, it's not yet compatible with the standard, but we will provide software upgrades as the standard completes so that it will remain compatible. So this is our strategy. So then jumping to different perspective completely now here next. And while doing that, if you have questions, you can of course type them in here. I don't see yet any questions, but feel free to do so. So sharing the knowledge. So we work together with already with companies like Schneider, Utunga, BE Services, and we hope to bring more companies to sharing knowledge, more individuals, experts sharing the knowledge. And a few points on that. So first of all, next week there is a major trade fair, SPS in Nuremberg, and there we will have an event. This is hosted by OPC Foundation. There will be an event called OPC UA FX Learn at Lunch. So there will be a box lunch available, and there will be presentations about OPC UA FX. So here is a registration QR code and link. If you want to join, please register so we know how many people are coming and we can have the lunch available. And this is in the trade fair area, basically in the conference center and the room Shanghai there. So if you are there, please register, join. Let's see there. Now sharing on this more information, and I have found it challenging to get the latest information and get questions answered about the OPC UA FX technology. And so we started this webinar series to help with that and to share knowledge. This is vendor neutral webinar series. So anyone can join and present. You can share, information with your company's template or your personal template or whatever you like. But this is not a product presentation. So it's not the idea to promote your own products. You can mention your products and where you are briefly, but it is not the kind of this is not a sales presentation. This is information sharing and helping everyone to understand the technology better. So if you want to present, we would be really happy to have you here. We keep doing this. We store the webinars to this YouTube channel, which you see there. You can contact Chhatrapati or you can contact me. And really, Utunga's role here, and Chhatrapati here, and Utunga team, they are hosting these webinars. They are sharing this information. So they are working together with all of us to make sharing this information possible. So that's important to understand. And then the OPC UA FX professionals community. So there is a LinkedIn group called OPC UA FX professionals. So we invite you to join there. You can ask questions from experts. You can share your knowledge. You can share your kind of experiments or findings or useful things there. And this way we help each other to develop the technology further and develop the products faster. So please join both if you like. We'll be happy to have you there. As well, if you post in LinkedIn, please use the OPC UA FX hashtag. That helps to kind of share the information with those people who are interested in this, and of course, then look for the OPC UA FX hashtag in your LinkedIn stream, and to learn more about the latest. So that's it, and we have about 9 minutes remaining, and now I would like to move to the Q&A section, and I'm happy to see comments here. So Melvin, thank you. Great presentation, folks. Interested to see the OPC UA FX Beer Conference in action. So come to the SPS trade fair. So yeah, thank you, Melvin. So looking forward to work with you more. So so that's all great, and I'm still giving everyone a minute, maybe to enter further questions. But if you have questions to me, to Melvin, or anyone else here, or if you don't know who to ask, join the LinkedIn group and post a question over there. So that's what it is for. So if you want to ask a question you don't have answer for, let the community of experts help you. And we are growing this group. We will start now kind of inviting more experts to it. It is still a relatively small group, but we will invite more experts to join and share the knowledge. So thank you for that. Okay, thank you. Okay, thanks for. Okay, good, great. So thank you everyone for joining the webinar. This was really exciting. I hope that you can find there useful bits and pieces of information, maybe connect dots that you were not sure about. If you were an automation expert, then you had already previous knowledge about many of the things, but I wanted to kind of recap those. And then there may be new information in the kind of the standard development and product cycles and things like that for everyone, which is upcoming. So next year, C2C products, we expect there to be C2D products in 2026, starting from there. So I think the market is now moving nicely forward, and I hope we can together educate each other and move it forward. So looking forward to that. Okay. All right. Okay, good. Well, that's all then. Thank you. And we will continue this webinar series. So I don't have a date yet for the next one, but there will be next one. We will continue doing this and sharing knowledge. So see you there or see you at the SPS. Okay. Thank you and bye.